Hello and welcome back. Today we'll be doing question 2 from the 2012 STEP Paper 3. So, let's get started. Question 2. In this question, the modulus of x is less than 1 and you may ignore issues of convergence. Part 1. Simplify 1 minus x, 1 plus x, 1 plus x squared, 1 plus x to the 4, all the way to 1 plus x to the 2 to the n, where n is a positive integer, and deduce that 1 over 1 minus x is equal to 1 plus x squared, 1 plus x to the 4, all the way to 1 plus x to the 2 to the n plus x to the 2 to the n plus 1 over 1 minus x. Deduce further that the natural log of 1 minus x is equal to the negative of the sum from r equals 0 to r equals infinity of the natural log of 1 plus x to the 2 to the r, and hence that 1 over 1 minus x is equal to 1 over 1 plus x plus 2x over 1 plus x squared plus 4x cubed over 1 plus x to the 4, etc. Part 2. Show that 1 plus 2x over 1 plus x squared is equal to 1 minus 2x over 1 minus x plus x squared plus 2x minus 4x cubed over 1 minus x squared plus x to the 4 plus 4x cubed minus 8x to the 7 over 1 minus x to the 4 plus x to the 8 all the way to infinity. Pause the video to have a think, and once you're ready, restart to see if you were correct. So, let's get started with part 1. Firstly, we'll write out the original equation, and then we'll use difference of two squares repeatedly to obtain the first simplification, that is, 1 minus x to the 2 to the n plus 1. If we now divide both sides by 1 minus x, we can obtain that 1 plus x squared, 1 plus x to the 4, all the way to 1 plus x to the 2 to the n, is equal to 1 minus x to the 2 to the n plus 1, all over 1 minus x. This rearranges to 1 over 1 minus x equals 1 plus x squared, 1 plus x to the 4, all the way to 1 plus x to the 2 to the n, plus x to the 2 to the n plus 1 over 1 minus x, as required. If we take the limit of the above as n tends towards infinity, then we can obtain 1 over 1 minus x is equal to 1 plus x squared, 1 plus x to the 4, all the way to infinity. Since the limit, as n tends towards infinity, of x to the 2 to the n plus 1 over 1 minus x is 0, because the modulus of x is smaller than 1. Taking logarithms here gives the negative natural log of 1 minus x is equal to the sum from r equals 0 to r equals infinity of the natural log of 1 plus x to the 2 to the r, as required. Differentiating both sides then gives 1 over 1 minus x is equal to 1 over 1 plus x plus 2x over 1 plus x squared plus 4x cubed over 1 plus x to the 4 all the way to infinity, as required. Part 2. If the statement is said to be true, then by integrating both sides, we can obtain the negative natural log of 1 plus x squared is equal to the sum from r equals 0 to r equals infinity of the natural log of 1 minus x to the 2 to the r plus x to the 2 to the r plus 1. Continuing backwards along the method in part 1, we obtain 1 over 1 plus x squared is equal to 1 minus x squared, 1 minus x squared plus x to the 4, all the way to infinity, which is equal to 1 minus x squared, 1 minus x squared plus x to the 4, all the way to 1 minus x to the 2 to the n, plus x to the 2 to the n plus 1, plus x to the 2 to the n plus 1, plus x to the 2 to the n plus 2, all over 1 plus x squared. And therefore, this equation can be obtained by a similar method to part 1 using this here. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.